Welcome back, everyone. Today I'll be looking at another DockerCon 2020 session, doing a live, well, not live, but doing a reaction of a recording from live session at DockerCon. So this one's going to be look at Docker files, I believe, and ways to optimize maybe. Let's get into it.
Hi, this is going to be a talk about building a Docker image packaging pipeline using GitHub Actions. I'm Gareth Rushgrove. I'm one of the directors of product at a company called Sneak that focuses on security for developers.
Snake, is that like the sound in the comics where Wolverine gets his claws out? Is that Snake? I don't know.
I'm also the curator of the DevOps Weekly newsletter and a fairly regular open source contributor, including to the Open Policy Agent project. In this talk, I'm going to talk through some concepts around reusable Docker files. I'm also then going to talk separately about GitHub Actions, and in particular the new build push action from Docker. I'm then going to bring those two topics together with a real-world example of building out a packaging pipeline for Docker images. So, Docker files, everyone's favorite topic, hopefully. Docker files may I see as the de facto standard for building container images. Take a Docker file, run Docker build, get an image. It's lots of people's first experience with Docker and building out things in the container space. But what does Dockerfile actually do? Under the hood, it's really, I think for me, it creates a file system and it adds some metadata. So you can break down most of the commands, sort of from, work, dir, add, copy, etc., label, to things that either work on the file system or add metadata to the image. In the beginning, Docker files are incredibly simple, right? Like we have one Docker file, we're building one image, we run it, and success. The issue is then that's such a good experience that we want to do it again. We look at our other applications, we talk to other teams about their applications. We build things that are based around a microservices architecture. And over time, we end up with a lot of individual Docker files, building a lot of individual containers.
Or one Docker file that's bloated that has everything thrown into it. That's another route.
And with enough time, that can get out of hand. You can have an awful lot of Docker files in different repositories in the same repository, often all with the same file name, and sharing an awful lot of the content in the files. There's a lot of duplication there from sort of copy and paste over a period of time. That's not great from a maintenance perspective if you need to change one of those things.
Or you can have a series of images. You can have one base image that has, let's say, has Java in it, and then you have multiple images deriving or building from that image for your Java applications. That's one way.
So what can we do about that? The good news there is actually there are a number of features within Dockerfile itself without you having to go and reach to add other tools or add sort of templating or whatever it might be. Let's start with a simple example of a Dockerfile and look at one of those features that provides a useful sort of reuse capability. So here's a Dockerfile example just with a couple of lines. The first one is probably familiar to everyone. It's going to basically we're saying, let's start with the Alpine image as our base. The next line is simply copying in an executable from another image. So here we're saying copy from the image called Open Policy Agent conftest at this tag, so 0.18.2. Copy the file system that's at /conftest into the image we will build from this Docker file. But there's something interesting there. Like, and implicitly, that v0.18.2 is a version number. But we have to pass that out manually. Well, is that the latest version? What happens when we increment it? Do we just simply create another Docker file? Do we replace this one? Build args are a capability in Dockerfile that allows us to be a bit cleverer. We can actually explicitly say this is a variable. In this case, I've called that version. And we then say, using Dockerfile, that this Dockerfile takes a build argument called version. And in this case, I've set up a default value using the same number. If we run either of these two Docker files, the before or after, just with Docker build, we get the exact same result. But the power comes that we can now override that default value using the --build arg on this command line. So we've got something that's immediately a bit more reusable. You can actually keep going with this, even with this simple example. Maybe this is a little bit contrived, but I think it proves a point. Here we're actually abstracting everything out into arguments. So again, this Docker file would do exactly the same as the other two if you ran it. But now you can pass in a different image, a different file path, a different label. So you can actually, in theory, use this to download any executable from any Docker file you choose, all actually just using build args rather than any logic in Dockerfile itself. What this allows us to do is, in lots of cases, go from that sort of one Docker file per image to one Docker file for many images. You might be able to get down to some sort of mythical one Docker file to rule them all. But that's probably not the ideal destination. But some level of abstraction, some level of reuse, especially within your team, is most likely useful. There are actually a number of other sort of powerful tricks and tools within Dockerfile that I think are relatively rarely used. This blog post is a great source of ideas and tips. The advanced multi-stage build patterns from Tonis, who's one of the engineers at Docker. This covers aliases, inheritance, logic, various different things you probably didn't think you could do with a declarative.
The multi-stage builds are actually helpful sometimes to shrink the size of your final image, because you could have, let's say you're building something in the first stage and you have all these dependencies and all these packages you want to install to do the build, and each one of those commands produces a layer in the image, which takes up more space in the size of the image. But then at the very end, you get an executable, and you can, in the second stage, you can actually copy that executable from the first stage and put it into your second image. So the first image is, think of it as just a temporary image, and then the second stage is going to create your image that you're going to use, and that is going to be done with far fewer layers and packages installed. Even if you uninstalled the packages and removed everything you needed and all you had left was the executable in the first stage, you still have the layers, so that's taking up space. So this is one way you can reduce the size of your images and kind of conceptually, keep different parts of your process separated. That makes sense.
Format. Okay, so that's a very quick look at a topic that we probably know lots about in Dockerfile. Let's jump into GitHub Actions. For those that haven't had much of a chance to play with GitHub Actions yet, they're often seen as, well, GitHub's built-in CI system. And yes, you can treat them like that, but they're actually a bit more interesting as well. Ultimately, you can run a workflow on any GitHub event. So if you want to run something on when an issue is created or a pull request is opened, or when a tag is put onto the repository, you can do so. And you can combine that with lots of different off-the-shelf actions that people build. So at a basic level, well, you can run shell commands and you can describe that workflow in a YAML file. So that's stored in your repository, just at .github/workflows. And here's a simple example from .NET. Here we're checking out the code, we're installing .NET itself, installing the dependencies of your application, building your application, and finally testing it. So a classic CI workflow. The good news for those building Docker images or using Docker for other things is that GitHub Actions uses Docker under the hood and exposes that to end users. So all of the standard Docker commands just work out of the box without you having to do anything. So here's an example of building a Docker file using the classic, building a Docker image using the classic docker build command. More recently, Docker have released the build push action. So it's open source on GitHub itself, and it's published to the GitHub Actions marketplace. But I said that you could use Docker with GitHub Actions already. Why do we need a separate action to do the same thing?
Yeah, I was just thinking that because I've hooked my GitLab repo to a Docker Hub and been able to trigger a build in Docker Hub of a Docker image with the push of, let's say, an updated Docker file. So yeah, I'm curious to see what's the advantage of this new way of doing things.
I think the distinction there is really that with the build push action, Docker have introduced a higher level declarative description of the build, rather than you having to understand the details of the commands you're running. In the trivial case, that's probably not much of a problem. You probably know how to run docker build -t tag, point it at a Docker file, away you go. And that's what you would achieve with what we see here. Here we're providing the username and password for authentication, so it avoids the need to auth separately. We're also providing the repository and some tags. But again, that's not too much of a distinction. But it gets more powerful in two different ways. The first one is integration into GitHub Actions itself. So take the idea of only pushing an image when you have a tag. A very common workflow that ultimately is really easy in declarative fashion here. So push is a Boolean, should we push or not? And all we're doing is saying, does the GitHub ref start with refs tags? Basically, is this a tag in GitHub sense? If it is, then not only will we push it to Docker Hub, we'll also tag it with that ref. We'll tag it with the tag. So our images are automatically tagged with our GitHub tags through a high-level interface without us having to worry here about what that tag is. And the action goes further than that as well, with a number of different built-in goodies, and all of which really lower the barrier to entry, I think, for good practice. So there's a number of these, tag with ref, tag with char. I really like the add git labels one, and we'll show a demo of that later on. So let's bring these two things together. The concept and problems really around reusable Docker files, and also GitHub Actions. At Sneak, we package up our software as a set of Docker images. This is available for people to look at this repository, so if you do want to dig into the demos I'm going to show, they're all more than demos, they're how we build our images here. Sneak ultimately provides a set of tools that allow developers to detect vulnerabilities in their software. So we make available that through a command line tool. There are IDE integrations as well as the Docker images. But let's look at the Docker images here. So let's grab in this case, a Go project, and let's run it through the Sneak Docker images. So Docker run, we pass in a Sneak token, basically an API token that gives you access to the vulnerability data. We mount the image, we mount the application source code into the image so we can parse out the dependencies and look for security problems. And then we just run that image. So in this case, Sneak Golang. In this case, actually, we didn't find any vulnerabilities, which is a good sign, but worth trying on your project. The thing I'd like to call out here is the Golang tag. Obviously, this is a Go project. But Sneak supports lots of different languages and frameworks. So .NET, PHP, JavaScript, Python, Java, Maven, Gradle, a wide range of different developer tools.
C++, please.
All that can have an influence on ultimately the vulnerabilities that we discover. Versions of Python being a good example. So we currently have 49 different images for different development environments, all up on Docker Hub. And we build all of these using 49 different GitHub action jobs. The nice thing by having separate jobs is GitHub is actually able to parallelize all those. So we build and push in parallel, normally in under 5 minutes, for all of those images. Each individual image might be built in less than 60 seconds. But at this point, some people will be thinking, wait a minute, there's 49 different action jobs? Like we started talking about sort of reuse and maintenance and lowering that sort of barrier. If we're having to scale this to 49 images and 49 different action jobs, what can we do? We'll come back to that in a second as well. So that job runs whenever we push changes to the repository, but it also runs on a regular schedule. It's a nice way of making sure we rebuild the images regularly, even if we're not adding new ones. Also, it allows us to pull in the new versions of Sneak and new versions of parent images as well on a regular basis. But we don't rebuild on documentation changes. You can be quite nuanced with GitHub Actions, which is a nice feature. Obviously, we don't want 49 different Docker files, and the title of the talk probably suggests that that's not what the approach we took. So actually, we have this down to one Docker file, and we do this using build arguments. We have an arg outside the target scope that can inject any arbitrary image. So instead of it being from Alpine, ultimately it's from some variable. That variable might be Alpine, but it could be Java or Python or Ruby or Node or whatever it might be. So we've got an incredibly powerful build process that takes as input another image. We have code in there, a little bit verbose, but to download the latest Sneak releases, does some double checking and then moving the executables into the path. And then targets for building an Alpine variant images and other Linux distribution versions. This is down to the different C compilers in Alpine and most of the Linux distros, so musl libc and glibc, and the different versions of Sneak built for those two systems. But we've got it down to one Docker file that needs some inputs. But we've now got these 49 jobs in our case in GitHub Actions, but it ultimately could be any system. Well, what we do there, instead of manually maintaining those 49 individual jobs, is we generate those. So the overall solution has one Docker file and 2 GitHub Actions. The second GitHub action, or the first in the logical order of things, runs when the build file changes or the configuration file changes, not on any other changes. And it's not run periodically because those things, it's purely based on those inputs. That generates a matrix in the second GitHub action with the inputs for the Docker file. So base, tag, target in our case. And those are input into the build push action. So along with our username credentials for Docker Hub, again, I mentioned we use the add git labels flag. And you can see the matrix building out the sort of the target, the tags, the actual build args for the image we're going to use as the base. We'll see that working in a second. I mentioned the labels and I'd show you later, but all of the images automatically have labels on them with the revision, with the source repository, and when they were created. All just from having set that in the image. One of my favorite features, so I thought I'd show it a quick demo. Okay, let's have a demo of some of this working. I've got the repository checked out of our build tool chain here.
Wow, there's that unusual terminal symbol there. Looks like a USB sign or something.
One of the things I didn't show was the input files. So this is a list of the base images we're going to build images for Sneak based on, like with Sneak included. As you can see, this is really the only thing we need to maintain by hand, but this is the things that we want, so that's okay. One of the things I just noticed was when Node 14 is out, and we're missing a Node 14 image. So let's do a quick live demo and hope this works out. So all I'm saying there is actually we want to build an image based on Node 14, and we'll give it the Node 14 tag. So we've just got that file changed. Let's.
Oh, it's Git. Yeah.
Let's push that up to our repository. Let's head over to our repository and have a look at what's happening. Here's the interesting one. So we detected GitHub detected a change in the config files and is running the generate action. Under the hood, this runs a simple script with some templates. And then it also commits back to the same repository. So if we do git pull, we should see some changes. Here you can see there was a method file changed, but also we changed one of the GitHub actions itself. And we now have Node 14 in here. That in turn triggered another the second GitHub action to run, and that's now busy building the images. So here you can see all of the images being built, and we should see a Node 14 one built.
Okay, so he's got an action. So he did a commit, which triggered an action, which changed the metadata, and this build matrix, and committed it, which then triggered another action to build all the images. Whew.
We won't wait for that to be built, but that will be built and tagged and pushed up to GitHub shortly. So that's all hands off. With that toolchain, we maintain one Docker file. We maintain really a set of tools that generate GitHub actions and a very simple configuration file at the top. So if all you remembered after watching this talk is a few takeaways, like one is it's worth learning Dockerfile. You've probably been using Dockerfile for quite a while, but I bet you there are some like hidden features or just things you don't know about it. It's worth looking through the documentation and the blog post I mentioned earlier. And if you understand the low-level tools, you'll find high-level uses like this one. I think one of the reasons that happens is, and one of the cases when it happens is when you bring that automation closer to developers. Ultimately, if automation is sort of someone else's problem and it's over the hill somewhere, you might touch it sometimes, but you'll probably do so through with a bit of friction. I think the more you can identify programmatic solutions to those sorts of repetitive problems, the better job you can do.
Yeah, that's actually, I can relate to that. Actually spent some time when I first started as a software engineer at college. My first job, well, it was a software engineer job, but my first few months was in QA or testing. Wasn't actually writing code, but I tackled the problem from a programmer's perspective, and I had to test these functions that had many arguments to them with different possible values, like an enum or something, multiple values. So there was many different combinations to test this function, and sometimes the function would be valid, like that combination of parameters and values would be valid, and sometimes it would be invalid and it would return an error. So I ended up writing this script that would create a test for every single combination, and then reading the requirements for this function, I would guess which, I mean, based on the requirements, I knew which one should fail and which one should succeed, but I didn't know if the code actually did that, so it was a guess. And I'd match it up. I probably had like over 5,000 tests. Never would have written all those by hand. No one would have. And I did find about a dozen cases where the function did not behave as expected from the requirements. And all because took a programmer's perspective on a solution like this for a repetitive problem. So this is pretty interesting. I don't know if I would ever have 40 plus images for one thing, but it's pretty nice.
And finally, sometimes it's worth, and often I think worth, focusing on maintenance. Like, the value of reducing the overhead of ongoing work is, I think, often underestimated. And this is a good example where this sort of build process it's completely hands-off. It builds new images, keeps them up to date. When there are new versions of software available, new versions of images available, and when we want to publish new ones, it's simply a single line added to a config file. Maybe we could automate some of that a bit further, but that's the job for another day. Thanks a lot for listening, and hopefully you found the talk and the demonstrations useful. If you're interested in Snyk itself and testing your applications for vulnerabilities, please do head over to snyk.io/signup and sign up for free. Thanks a lot, and have a good rest of DockerCon.
That was a pretty good one. I liked it. So I hope you enjoyed the video. If you did, smash that like button and consider subscribing to see more videos like this. I typically try to keep it to either software or computers in general. So if you like that kind of thing, consider subscribing. Until next time, bye.